Hey, good morning, good afternoon, everyone. Can everyone see my slide?
Yes, of course.
Okay, cool, thank you. I just wanted to try that.
Hi, everyone. We'll get going in just a minute or two here. Love seeing our global group come together. I see Germany and South Africa and Korea and the United States. Finland. Got people from all over today.
And the UK.
In the UK.
Poland is here too, by the way. Hello, everyone.
Speaking of South Africa, Rian, I've realised I've been misspelling your name for the last month. I do apologise. I've just realised, and I put 2 A's instead of 2 N's in it. That's my bad.
No worries. Still work.
And Dzień dobry, Poland.
That was
Good.
almost perfect. That was pretty nice.
I get the 20 Zoom windows arrayed so I can see what's going on. All right, I think we are doing pretty good with attendance, so we'll get going in just a sec here. Mike Rossell, would you like to buddy check me? Is today, in fact, November 30th?
Today is certainly in the time zone I'm in, November the 30th. So let's assume that it is for most of us.
All right. Did I get the year right too?
Yeah, looks good to me.
Right, we're off to a good start then. All right, well, let's get underway. Today, as we've just certified in some parts of the world, is November 30th in the year 2023, and this is the Technical Advisory Council meeting of the Confidential Computing Consortium. We are an open and collaborative organization. Everybody is welcome to join the meetings and contribute in all ways possible. We ask that you abide by our contributor code of conduct, and that's available in any of our repositories. But it basically just says, be constructive. We also abide by the Linux Foundation's antitrust policy notice. If you want to find out more about that, you can go to linuxfoundation.org/antitrust-policy. We have a rather jam-packed agenda for today. After going through our normal startup procedures here, we'll be coming back to the islet project, and go through the project submission template and ideally bring that project to a vote. And then we have a new project being introduced today, the Coconut SVSM project. And then, time permitting, we will get into we'll introduce a SIG proposal that's been on the GitHub for a few weeks now, and maybe get into finalizing some of our 2023 accomplishments and the 2024 priorities. Were there any other significant agenda items that anybody expected on the list today?
No, but I'd like to add one, if I may, please.
You may try.
Which is at least a brief discussion about time zone meetings for Asia Pac friendly.
Sure. Why don't we throw
We've had
that
a bit
in
of discussion on the email, but it'd be good to have a bit of that in person, but a synchronous discussion.
Okay, so we can try to do a little of that. We'll throw it into the action item review.
Thank you.
All right, anything else? All right, so we're going to go into roll call next, but if we haven't had an introduction from you in the past, at least twice, we'll be asking you to, if you're interested in it, to introduce yourself to the community and let us know your name, your pronouns, where you're joining from, either geographically or what company you're joining from, and what your confidential computing interest is. So you can think about your answers to those questions, but this is all very informal. While we go through the formal roll call for the voting members of the TAC. Do we have Accenture in attendance? I think not.
Accenture are no longer members, so we could probably remove them.
Yeah, so they're members through the end of the calendar year, I think.
I'm
and then,
sorry, you may well be right. Okay, sorry.
Yep. So they've got another month to assert their position. Anyway, ARM. Do we have Nathaniel or Michael?
Yes, Nathaniel's here.
Thank you, Nathaniel. Meta, Eric or Shankaran? No. Okay. Google, Kafir or Catalan? Nope. Howard. No Howard today. All right, I am here for Intel. Do we have an Alec?
I'm here, but I need to leave after the top of the hour.
Okay. And then Red Hat, Lily and or Yash.
I'm here.
Hey, Lily. So I think that brings us to quorum. Somebody can double check that I can still count to 4 correctly.
You are sorry, you are correct. We have quorum.
Excellent. All right, well, let's get into introducing any new members out there in the community who would like to introduce themselves. Again, this is very informal, but it's part of having a good collaborative community that we all feel like we know roughly who everybody else is and feel comfortable speaking up. So feel free to just pop off of mute and step on somebody else. We'll just sort that out the way that it normally happens.
Hello, everyone. Can you hear me?
Yes.
Okay. My name is Piotr Sawicki. I work at Samsung R&D Institute Poland, and I collaborate with Mrs. Bogduk team on the ILET project. It's a pleasure to be here. Thanks.
Okay. Thank you, Piotr.
Yeah, same story for me. I'm working with Bogdan and Peter, also from Poland, joining in from the office. Nice to see you, everyone.
Thank you. Thanks.
Just about everyone new. Hi, everyone. Salkamek. I've been on this call a couple of times before, but I will be joining later in December formally as the CCC's technical community sort of architect. So very glad to be here and hope to be in touch with all of you.
Welcome, Sal.
Thank you.
Yes,
Glad to be here.
very excited to have Sal joining us.
Me too.
Talk more about Sal's role as that becomes official, I guess, at the end of the month.
Hey everyone, don't know if you can hear me. I had problems with my microphone a second ago. You can, good, great. I'm sort of new here. I used to join these meetings as part of R3. I've moved on from R3 now. I'm now working at SUSE. And my interest in confidential computing, it's long and varied from SGX through to current position, working with Jorg on Coconut SVSM. So pleased to meet you all.
Great having you. Thanks.
Hi, I'm Caffrey Sheldon. I'm from Broadcom now, used to be VMware. And I work in our virtualization team.
Thanks for joining today. We have a number of VMware contributors. I guess we need to refer to you as Broadcom contributors now. Is that right?
That's the case.
All right.
Hi, this is Bodo, product manager in VMware and now Broadcom. First time in the meeting. Good to see everyone.
Thanks for joining.
Hi, I'm Tom. I don't actually work in confidential computing right now, but
I'm just doing this as my hobby, and that's also my interest, just research, some programming. Yeah.
That's great, Tom. Everybody is encouraged to learn and contribute how they can here. So definitely don't need a company affiliation to be here. All right, that was a good list of new contributors here in the meeting. And if you were still hoping to come off mute and introduce yourself, feel free to do that. Otherwise, I will move us on in just a sec here. So I think in the interest of time, I'm not going to go through the formal vote for the TAC minutes. I think we're going to start experimenting with just approving these offline using GitHub approvals and save ourselves a little bit of time in the meeting. All of our minutes are recorded publicly though, and that kind of helps us when we need to go back in time and remember, did we make a decision? How did we make a decision? We get some sort of consistency out of doing that. But we will move on today. We already had some proactive approvals on the PR for those minutes. So we wanted to add one other thing for today, which was the time zone. And I lied when I made this slide that I had completed this GitHub issue because I had almost written it out. So we're going to call that in progress still. But I will preview what I will put up as a GitHub issue, which is the issue here is that as we've added more projects and we've got 2 more on the docket to discuss today, it's been difficult to have the voting members of the TAC or other members of the TAC be able to cover all of the projects. And so we need to talk about more scalable ways to do that. One method is that we just start going and directly assigning. So people will end up needing to double up in some cases on projects, but kind of going through in a round robin basis for those of us who have responsibility as TAC voting members. Second is that we just drop the role entirely. And then the third, which comes from some thoughts from Lily, is that we could actually branch into having more domain-specific mentoring. So each one of us has some specialties, and then we can offer those as topics that project maintainers can reach out to us on. So that strikes me as a more scalable mechanism. But I'll write that up better probably sometime today or tomorrow and put it in the GitHub issue. Any questions on that before we move on? Okay, Mike, would you like to lead a few minutes of discussion on the time zone challenge?
Yeah, great. So we've had we're trying to grow our presence and engagement with Asia Pac. We've got a number of Asia Pac members and also a number of members who have employees in Asia Pac who would like to be getting more involved with what we're doing. Currently, our meetings are not Asia Pac friendly, and I've had requests from a number of companies to find some times that are. There seem to be 2 options, both of which involve being in the middle of an ocean, really. One is to kind of move to something which is Atlantic friendly and kind of maybe European time zone based. And the other is to move something which is more sort of Pacific friendly and more Hawaiian based, basically. And there are positives and negatives for both. One thing I've heard from at least one member who's based in China was that they have people staying up anyway late for a number of calls. And the last thing they want to be doing is getting up early, which kind of militates against a sort of Pacific view, whereas an Atlantic view makes it easier for them generally. It also means that we get more European folks in. Obviously, it's more difficult for West Coast folks. And I think basically what we're going to have to come to terms with is that there will be meetings that not everyone can get to. And I think that's fine. We record these. And if people want to get up early or stay up late, they can do so. But I think we should be having a cadence which is, I think, a little more fair, because it is very, very harsh on our Asia Pac members who we want to have more of, and we want to get more engaged with these things. So my thinking is that we should maybe have one TAC in 4, and the same possibly goes for the SIGs, which is aimed to be at sort of, I don't know, morning UK time, morning European time, which would be afternoon rather than late evening for our friends in Asia Pac, and which we record. But let's have the discussion.
Thanks for walking us through that, Mike. So if you go out to the TAC mail-in list, there's a few notes on this right now. So if you want to put thoughts into that, feel free to do it. And I think what I would like to see is that we try something new at the beginning of 2024, and we might find that we move that around as we settle in on something that will eventually work better for everyone. All right, so that brings us up to ILET. So if I can either bring up the project submission template that you sent out to the mail list, BuckDuck, or you're welcome to share your screen, however you would prefer to do this.
You say that again, sorry.
I was inviting.
I will share my own screen.
Okay, I will stop sharing then. And so for everybody's benefit, in the mail list post for the agenda, there's links to these documents, so you can bring them up yourself at your own desk if you like. But we ask project submitters to fill out a couple of forms. One is pretty pro forma about the governance structure for the project, mostly involves just filling in the project name, and the other one is a little bit more substantive, which talks in more detail about the things that we want to review as a technical advisory council. And that is the document that BuckDuck has open now.
So in general information, it includes the name of project, islet, which also means a small island. So I think island, calling island is still okay. And under the project description, I mentioned that the islet is an open source project providing the confidential computing platform for on ARM architecture, especially using ARMv9 CCA features. And it consists of 2 key components. One is RAM management monitor, and the another is hardware enforced security. And those are blue ones. And RMM is running on the main application processor, and meanwhile HES has it in a separate secure module running on another module.
And do you want to remind us what those acronyms refer to?
RAM management monitor, and the on ARM defined a new terminology called RAM, and it is also it means the confidential virtual machines, and the RAM management monitor manages the RAMs. And the HES means the hardware enforced security, and it takes a role to managing the secure device boot measurement and generating the platform attestation reports. And although it is not currently implemented, but it will manage the selling key functionality as well. And I introduced what will ILET design will be. And I emphasize that for the security reasons, we chose to use Rust program language, and it is known for a security model that ensures memory safety and concurrency safety. And while we exploiting the benefits of the Rust safeness with the Rust compile time safety validation, I introduced that we can design RAM management monitor to be able to be customizable for each purpose like IoT or wearables and mobile phones, but it still keeps the safeness. And our future in our future, we are going to provide formal verification, apply formal verification to all our implementation and design. And during the last ILED introduction, I introduced that what's the main purpose of the ILED, and I introduced that the ILED is the main goal of the ILED is to protect user privacy on end user devices. And why I here at the first section phrase, I introduced why it is important to protect user privacy using confidential computing. And the second bullet, I mentioned that the ILED's strategy about its own implementation, and ILED is going to implement on-device use cases as well on the ILED platform, and identify during developing the use cases, we will identify additional features that will be needed to support them. And by doing this use case based focused approach, we believe that it will bring unique improvements to CC platform for user devices and accelerate adoption by demonstrating how confidential computing can be used in visible manner on these devices. And by introducing the first two bullets, it can diversify the confidential computing landscape. And I mentioned our history, and I started our own project last year. And this is the second year of the project. And regarding the how it is aligned with CCC's mission statement, I firstly mentioned that as it is also mentioned in the CCC mission statement, ILED can also contribute to accelerate the acceptance and adoption of confidential computing by defining the confidential platform for ARM devices and demonstrating its practical use cases in visible manner. And in the second bullet, the benefits, I mentioned the benefits of its own design in terms of extensible and customizable CC platform. And it will take a role as a building block of the software platform. And finally, it has also ILED also has an open collaboration with other projects, and we are currently collaborating with VMware and Broadcom certifier framework. And we have our own website here. Do you want me to open the website?
No, I think that's fine.
Okay.
People can check that out if they like.
Okay. we don't have any social media accounts yet. And we have our own logo. We recently created the logo. And the license of the project is Apache 2.0. And as it is a company project initiated by the company, so it is, yeah, it is going to continue this way for in the future as well. And we don't have a trademark protected. And regarding the technical information about the synergy with the existing project and the any overlapping project, and how we can harmonize, potential ways to harmonize over time. And to gear up the full confidential computing software stack on end user devices, we are using or in collaboration with other projects like a VMware Certifier Framework. And we are also supporting the Verizon project for attestation. And by joining the CCC project, we are also we hope we'll get another opportunity to collaborate with other projects, like the project that builds the CC runtime project, like NWorks. And the ALED is implementing the specification, which is for the RAM management monitor, and it is defined by ARM. So again, ALED is not just a standalone project. It already depends on other project and has an interaction or a collaboration with other projects. And another project that is overlapping is, although it is not under CCC project, there is a TFRMM and TFM runtime security service project, and it is mainly contributed by ARM. And I mentioned that the difference between the two projects, I mean the ALED and the TF Trusted Firmware project, and it is there is a difference in terms of language and the targets they're going to deploy. And the most, however,
those, sorry to interrupt, those two third-party projects, those are also open source, I assume?
Yeah, they are open source. And when we started our own project, we started from last year, we started from scratch, but this year we changed our project to support the RMM specification from ARM. So for that, we took a reference from TFRMM and the TFM projects.
Okay, great.
And there are much similarity.
Okay.
Okay.
I'm also reminded that one of the questions that came up last time was, as a end user device oriented project, you've got a different threat model than some of the other projects that we already have in the CCC, in that the physical security of the device is in play in a different way than something that's housed in a restricted data center. And so I think we had some questions about that, and the physical security claims for the CCC, for the CCA architecture weren't clear at the time. So I don't know if it might have been Kafir that had asked that, but I think there was a couple people that had asked related things.
Oh, I thought I wasn't prepared for that question.
No, that's fine. I'm asking because we've got we've got some ARM folks on the call this time, and they might be able to answer that, or if that's not an issue for people who would ask that question before, we could also move on.
Yeah, currently we are relying on all the security features, mitigation features for to protect from the attacks. And according, are there any ARM folks who can answer this question?
Yeah, you've got Mark and Nathaniel on the call here. Nathaniel, did you want to step in? And it wasn't clear to me what the ask was, but I think we.
Yeah, it's the same from me. I'm not quite sure what the question is, but I'm happy to help.
If I recall correctly, it was really about what is the plan for protecting against adversaries with physical possession of the device? And does ARM have, I don't know, maybe packaging solutions or things in mind to help with the security of those, general purpose processors that include a trusted execution capability?
So we don't view them as we don't view the two use cases as fundamentally different. So both use cases, both the data center use case and like a traditional client device, would have similar threat models from our perspective. In terms of our root of trust, we do as ARM provide that for our partners. They can use that root of trust as IP to build a secure package, but of course, we don't as a company actually build the physical chips. So that's up to our partners to build that into their processes.
Do you happen to know of any licensees that are considering tamper-resistant, tamper-evident designs?
Not that I can speak publicly about.
Thank you.
From my point of view, I would hope that this wasn't seen as an impediment to joining. I think it's useful information, but it's again about raising the bar significantly. No one pretends that security is ever going to be perfect, and I think this is a really interesting project, and it certainly raises the bar. So from my point of view, that shouldn't be an impediment to joining at all.
Yeah, I don't think the person who asked that question intended it to be. I think it was a general interest question, not one related to the product.
Yeah, I think the important takeaway is that the security protections that are provided, are on a chip-by-chip basis in terms of physical security, but in terms of the design of the system, there is not a difference in threat model regarding physical access from an IP or instruction set perspective.
Okay. We can move along then.
Okay. And I added the trusted computing base, and there will be two trusted computing bases for each islet RMM and islet HES, and it depends on hardware. And let me go back to the architecture diagram. It will be much easier. So here do you see my mouse pointer as well?
Yeah, we do.
Okay. Thank you. And here it will be running on the main processor. So as outlet is running at the exception level 2, it relies on all the underlying software stacks, including the secure monitor, which is running at the exception level 3, and all the secure boot related firmwares. Outlet also depends on that. And on the other hand, outlet HES is running on another secure subsystem, and it has its own processor, and it is another secure hardware IP. So it will have its own SoC and a firmware. And although we're because I draw it as a gray area because we don't have an actual hardware or firmware or OS or HES yet. So anyway, it will depend on it on underlying software stack. So that's the TCBs of the islet.
Great.
Okay, and I added the code of conduct, and there is no change of I took a reference from the existing project, so it is almost the same. And here's a link to the our islet project, and to track the issues, we are using the GitHub issues. And all the external dependency information, there are a lot of libraries we're using. So we listed up the external projects here.
Mm-hmm.
And regarding the standards implemented by the islet, as I mentioned, islet is implementing the RMM specification, and the rest of the list of the standards are related to attestation. And we are releasing islet via using GitHub. And the initial commuters are all from Samsung. And we don't have we have a channel, so we are using the discussion, GitHub discussion for the communication channel. And we also tested how we will respond to security issues. And the preferred maturity level is incubation, and that's the end of the submission form.
I think that was a very thorough job filling in all of that information. Anybody else in the TAC with open questions after having reviewed that? So a question that we commonly ask when we look at, if you scroll up just a little bit for me to the initial committers, is about diversity of companies participating. It's not a requirement for incubation, but as a project matures, it is important to have multiple companies, multiple stakeholders involved so that it can sort of survive the interests of one company changing or moving on with some other path.
So yeah, islet is welcome anyone who are interested in joining this project. So, but up until now, no one, anyone others outside from Samsung hasn't applied the contribution. There are several contributors, but they are not yet the initial commuters yet.
Okay, you've had contributions from other companies, is what you're saying?
Yes.
They're just not
Yeah.
maintainers.
Yeah, they are contributors, but they are not maintainers yet.
Okay, that's great. I
But we are
see
still
Samuel
open to
Ortiz
it.
has. Of course,
we are still open to it.
Okay, Samuel.
I'm just curious if there are other RMM open source implementation out there. Maybe
yeah.
that was answered. Are there other implementation for the RMM spec?
There are both the HES and the RMM have implementations in the Trusted Firmware project. They're written in, I believe, C.
Okay. I'm just curious, and maybe this is not something that can be answered in this meeting. But what is ARM's point of view on this implementation versus the trusted firmware? I mean, is there any ARM reference implementation for RMM, or it's just a spec that people are free to implement?
Yes, there is a reference implementation, which is TFRMM, that's written in C. I don't know that ARM has any official position regarding these implementations, but let me take off my ARM hat and just give a couple points of personal opinion. The first one is that I'm very glad to see people working on this project. I think it's great to have something that's written in Rust. I'm a huge fan of Rust, as people know, and I think that it's absolutely the right choice. I'm glad to help mentor in any way. The only concern I would ever have on this is about the question of how we generally avoid the problem of fragmentation of the TCB. And that's not a question targeted at this particular project. That's an open question within the entire ARM ecosystem. So basically, just I think we should find a way to collaborate more closely and see if we can find ways to avoid fragmentation anywhere we can.
Absolutely. Actually, we had a meeting with ARM. Chris had connected us with ARM developers. And one of the name was Simon Frost. We had a meeting about a month ago, and we tried to we talked to each other. We introduced our own project to each other, and we discussed how we can align those two projects together. But we don't have a final answer yet. But we will try to align the two projects.
Yeah, I think that would be great.
And again, this is a sort of work where hopefully being both members of the CCC helps. Part of the job of the TTA is to help projects align internally and, I suppose, externally. So it may be that a helping hand from the CCC will help.
Absolutely, and I'm in no ways opposed to this project on any grounds.
Right, and the alignment is a good way. And on my second thought is this is the beginning stage of the project, especially for the ARM world. So why don't we just have a diversity? And then we explore all of the spaces, and then later we can merge how we can merge the two projects. We can consider how to merge the project together.
Yeah, that seems to me like a reasonable path forward. The only thing I want to do is I want to cast that long-term vision of, in order to scale up confidential computing as a whole, we need to find ways to reduce TCB complexity. And this is not just an ARM-specific problem. This problem exists across the entire ecosystem. And measurement fragility in terms of attestation across the entire confidential computing ecosystem lends towards both comprehensibility issues and also scalability issues, and I'm interested in those being solved again for the whole consortium as a whole.
Great. Okay, so we are starting to wind down on time for this topic. I want to make sure that we answer all questions, though, especially from TAC members before we need to vote. Are there additional questions? Is there any TAC voting member that wants to make a motion to vote?
Before we do that, sorry, I just want to, we do try and vote by consensus. I think it'd be interesting to know if there's like to be anyone who doesn't think this is a good idea, whether they're voting members or not, and whether we can smooth any questions there. Does that make sense, Dan?
I think that's a great way to phrase that.
So does anyone have any concerns then about accepting this project before we go to a vote? That doesn't mean that it will go either way, but it's just good to know.
I have no concerns.
If anyone's on mute and has concerns, they might want to say it or put it on in the chat. But I think it's looking pretty good, honestly.
No concerns here.
So I suggest, Dan, we do take Nathaniel's request.
All right, let's go ahead and move to a roll call vote then. Having said that, I may as well get the TAC slides back up here. So starting with ARM, Nathaniel.
Aye.
Thank you. Google, Kafir. Thought I saw Kafir on the list. I guess maybe he dropped again. Okay. So we'll have to step over Google and onto me. So I vote in favor for Intel. Microsoft, Alec.
I vote aye.
All right. And then Lily from Red Hat.
We're in favor. Yash, would you confirm that?
Yes, we are in favor.
All right. So I get 4 votes. So that's everybody in attendance on the voting list. And so with that, I'd like to welcome Islet as the newest project to the CCC.
Well, you can't do that.
A little caveat,
yeah.
which Mike's going to catch me on. The next steps for you, and we will guide you through this offline, is it needs to go through a legal approval, and then we'll bring you to the board, and then you will officially be a CCC project. But I think this is really usually the most significant stage.
Yeah, we should say that the board has never gone against the recommendation of the TAC when welcoming a project. So it really is just hopefully little bits and pieces to sort. So fantastic work, Botju. Really, really great. Well done, everyone at Islet and Samsung. Really, really pleased for you.
Congratulations, and I'll be reaching out with some next steps of some forms we need to fill out. So we'll do that later. But thank you.
Thanks, Ben.
Thank you for your support.
Chris?
Yeah, this is to Mike. There is a backlog in the board of project approvals. Rust SPDM, the certifier, and now this. It would be super if that could be unblocked.
Yeah, I responded to you by email earlier on. That basically required that I don't know what stage they are, each of them, in terms of the legal stuff. Ben may be able to talk about that. You're quite right. We need to move these other projects forward, particularly the ones that have been waiting for a while. So, Ben, where are we, do you know, with the legal approval for Rust SPDM and Certifier?
Yeah, definitely. So Rust SPDM is the furthest along. Their participation agreement is all filled out. We're just waiting for confirmation on who will be the signatory for them, and then that project can go for a board vote. For Certifier, I reached out to VM a couple times to get the participation agreement signed, and I haven't heard back. So Chris, maybe I'll reach out to you, and maybe you can help me. Maybe I'm emailing the wrong person. But once that's set, that can be signed, and then we can also go for a board vote.
Which means that we're not ready for the board vote yet. There are some legal bits and pieces to happen first, Chris.
Correct. We don't want to go to the board until that participation agreement is settled.
We've been burnt by that before, which is
yeah.
Sounds good. Thank you very much.
Okay, great. So the next topic for today is the Coconut SVSM. I think we have Jörg on the call, so I can stop sharing, assuming that you want to bring up some slides.
Hi, everyone. Let me just share my screen. So, and Can you see my slides?
I can.
Great. So welcome everyone. I'm glad to be here to speak to you about my favorite topic, which is the Coconut Secure VM Service module. My name is Jörg Rödel. I work for SUSE. I formerly worked for AWS and AMD as a Linux kernel engineer, mainly on x86 architecture and virtualization, but also on IOMMUs. One of the tasks back then was to bring guest support for AMD SCVES to the Linux kernel in late 2022, which was actually the project that brought me into confidential computing and which made me interested in it. And I stayed with confidential computing, and in late 2022, I started a project to write a secure VM service module, or an SVSM, which reached a stage where it could be published in March 2023, where I made it public on at the OC3 conference on March 15. And since then, it's called the Coconut SVSM. But this raises the question, what is an SVSM, or why do we need an SVSM? So for that, let's have a look at the usual confidential virtual machine setup as we can implement it today. So we have our trusted execution environment, our virtualization-based trusted execution environment, which runs an operating system and which talks to the untrusted hypervisor. In this scenario, the interface of the confidential virtual machine and the OS to the hypervisor, to the untrusted hypervisor, is pretty big, because almost all virtualization functionality is still remaining in the hypervisor. This includes device emulation. This includes emulation for the TPM. This includes IRQ injection and even more things. The only thing in this scenario that is already happening inside the guest OS is the intercept handling, or most of the intercept handling, which is a necessity because otherwise we wouldn't have encrypted register state for the guest OS. But this situation is not optimal, because we have a pretty big interface between the guest OS and the untrusted hypervisor. Further, it requires an enlightened OS, so the OS needs to be enabled to actually run in that in a confidential environment. And I mentioned the big hypervisor interface, which requires the OS to actually be hardened against malicious input from the hypervisor. This includes device drivers, and this includes the IRQ handling, basically every part of the operating system that has some interface with the hypervisor. And even for some devices like TPMs that carry security sensitive state, it is not even possible to securely emulate that in the hypervisor context, because then the hypervisor would have access to the security sensitive state, which cannot be considered secure in a confidential computing environment. So with an SVSM, the idea is to provide an alternative and to reduce the hypervisor guest OS interface, and actually move some parts of the interface into the SVSM. So with an SVSM, the stack would look like this. We would have the SVSM running alongside the operating system within the trusted execution environment. Intercept handling still happens in the guest. But with an SVSM, we can actually move parts of the hypervisor functionality into guest context, where it becomes trusted, because it's running within the trusted execution environment. So it's also part of the initial attestation. So the code running there is also trusted by the guest, or can be trusted by the guest OS. The first use case is probably to move the TPM into guest context and make it secure and actually usable for runtime attestation within the confidential computing guest. Make it secure this way. Another possible use case is to move IRQ injection into the guest context, which removes the need in the guest OS to actually harden against malicious IRQ injection. Not all trusted execution environments need this, but some do. So that's another use case we are looking into. So with that, we only have device emulation left in the hypervisor. or normal device emulation, all devices except the TPM, and the confidential guest OS can talk to the SVSM, which is trusted and where does not need to expect malicious input. And so the interface to the hypervisor is actually reduced, which makes the overall setup more secure. So what you see in this picture is actually only one model of the SVSM execution. I call this the enlightened OS model, because in this scenario, the operating system still needs to be aware that it is running inside a confidential VM, and it needs to be aware that an SVSM is present. So it needs interfaces to the SVSM, and it needs to do special handling for handling intercepts, and also for other things like handling private and shared memory transitions. There are other models which are possible and envisioned for the Coconut SVSM. The next one is the Paravisor model, where we actually move almost all hypervisor functionality into guest context, move it into and execute it into the SVSM. So with trusted execution, with recently new trusted execution environments, we have the ability to actually move all device emulation into the guest OS, and also move intercept handling out of the guest OS into the SVSM, which allows us to actually execute operating systems in the trusted execution environment, which are not enabled for confidential computing by itself, which is also interesting because it broadens the scope of confidential computing and brings or makes more workloads runnable in a confidential computing environment. In this scenario,
I should have asked before you began, would you like to take questions as you go or take questions at the end?
I'd like to take questions at the end, please.
Okay.
So in this model, the only thing the hypervisor has to do is basically scheduling the guest vCPUs and injecting events to the SVSM. And besides these two models, there's a third model which is envisioned for the Coconut SVSM, which I call the service VM model, where the SVSM actually doesn't run alongside an operating system in a confidential VM, but runs standalone and executes services which can be made accessible to other confidential VMs. This is particularly interesting for trusted execution environments that do not support the hardware features to run an SVSM alongside an OS within the same virtual machine. So this is a model we also envision and we have on our list to support in the future. So I've just mentioned the hardware requirements for the enlightened OS and Paravisor modes. To actually make these operational modes possible, the SVSM needs memory isolation within a confidential virtual machine, or in the context of the confidential virtual machine. This is needed because the SVSM contains sensitive state, like the already mentioned TPM device state, which must not be accessible to the operating system. Otherwise, it would not be a secure TPM, right? So we need to have a way to ensure that the operating system does not have access to the memory of the SVSM. So this requires a memory isolation technique within the trusted execution environment. For now, we build on VM privilege levels of AMD SCV SNP, but a similar technique is upcoming for Intel TTX, which is TTX partitioning. On these platforms, when these features are available, the enlightened OS and Paravisor modes would be available to the SVSM. And if they are not available, then users can choose the service VM model of the SVSM. So a little bit more details on AMD SCV SNP privilege levels or VM privilege levels. The architecture has defined 4 of them: VMPL0 to VMPL3. VMPL0 is the most privileged one. It has special permissions. And in an SVSM scenario, the SVSM would run in VMPL0. and the operating system would run in a higher VMPL. For the Coconut SVSM, this is currently VMPL 2. And the interesting point is that AMD SCB SNP hardware provides the ability to actually mark memory accessible by a specific set of VMPLs only. So this can be used to make guest memory available only to VMPL 0 and basically disallow any higher VMPL to access this memory, which is the required memory isolation feature which we need for the Enlightened OS and Paravisor models. An interesting thing to note is that the VM privilege levels are orthogonal to the CPU privilege levels. So within each VMPL, we can have all 4 CPU privilege levels. So we can have software that executes at CPL 0 through to CPL 3, independently of any other VMPL. So we can have kernel and user mode split in each VMPL, basically. That is important later on, because the Coconut SVSM will make use of that in the future, which is one of the key points of the project. So now let's get into the Coconut SVSM. First of all, we have learned now what an SVSM is and what it's good for, what it does, but now it gets more specific to the Coconut SVSM. So what is the overall vision of the project? The overall vision is to become a generic platform for providing secure services to confidential VMs. The services we currently have in mind are listed here, or some of the services we have in mind, which is TPM, which I mentioned quite often already, live migration, possibly a variable store, and more services we haven't thought of yet. Paravisor mode probably also needs other services, but these are not listed here yet because we don't know yet which one. So this is the overall vision for the project. It wants to be a platform for several services for confidential VMs. In a nutshell, what is the project about? It's an OS level project, so it runs in CPU privilege level 0 in kernel mode. It currently has around 15,700 lines of Rust code. It has a community of around 20 to 30 people. To date, we have 17 code contributors. It's targeted only at virtualization-based trusted execution environments. Currently, it even only runs on AMD SCB SNP, but support for other virtualization-based TEs is possible and welcomed. So, like Intel TDX, and one of the main points for Coconut is that it puts a strong focus on isolation, even within the kernel, even within the SVSM kernel. What features do we currently have implemented? So the SVSM boots on the Linux KVM QEMU stack with Linux operating system as a guest on AMD SCB SNP hardware. We have an somewhat sophisticated memory allocator based on buddy and slab algorithms. We already have a RAM file system implemented. We have per CPU page tables, which are an isolation feature in the kernel, so that other CPUs cannot probe memory from your CPU. We already have an ELF loader, which we will need for loading the actual services. We have a virtual memory manager, basic task support, and we already run a couple of testing and quality assurance in CI. So we have unit tests, we run Clippy checks, we run Rust format checks to enforce coding style, and recently we also gained support for fuzzing several parts of the code base. We cannot fuzz the whole SVSM, but we can fuzz several parts, like the fuzzer for the RAM file system, for example. There's a fuzzer for ACPI parsing, and I think 2 more, which I don't recall right now. So we also do quite some. We also did quite some work on quality assurance too. The project is on GitHub. On this URL, you can check it out. Look at the code, make contributions if you want. It also contains detailed instructions on how to set it up and get it running on your side. There are a few company-owned repositories in the Coconut SVSM project for Linux kernel, for QEMU and for the firmware for OVMF, which all need extra support to support an SVSM, which is not yet upstream in these projects. So this is also needed, but all the details are in the installation documents. Some things about governance and license, because people are always interested in that. The project is dual license at MIT and Apache 2.0. It has currently only one maintainer, which is me. The plan is to extend that to 3 at some point, but we are not there yet. Code changes usually flow in via GitHub PRs. We have a community mailing list. We have a weekly development call happening every Wednesday. And we have a security email address where people can report security issues to, which is not that relevant yet, but I think will become relevant in the future. So this is where we are currently with the Coconut SVSM project. So what are the next steps? What do we plan for the future? One of the most important things that we want to implement, and which is our highest priority right now, is to implement modules which run in user mode, which means CPU privilege level 3. Modules are actually is actually our name for what in other operating systems is called a process or a task. And in the Coconut SVSM we call this modules, because modules are the pieces of software that will actually provide the services. So the services will not be provided by the SVSM kernel, but by modules running in user mode. The reason for that is, first of all, isolation, to isolate these services from the kernel and to isolate the services from each other, which is, I think, very important because the SVSM is a very security-sensitive piece of software. And having a significant amount of isolation within the SVSM is important to maintain security within the project. This is especially important since modules can be written in other languages than Rust. So when I was starting with the SVSM, I was looking into what it takes to get a TPM integrated, and I found that all software TPMs are written in C, and it's kind of problematic, or I found it kind of problematic to link 200,000 lines of Rust code for TPM and for the crypto library into a small Rust kernel that kind of eliminates the reason to use Rust. So I decided that we need some isolation between the Rust and possible C code. And that's how the decision was made to move modules and services to user mode in CPL3. For modules, we also need an IPC mechanism. The modules need to be able to talk to each other. Details are still to be defined. And the goal is that users can configure their SVSM with a custom set of modules. So users, which can, for example, be cloud service providers or Linux distributions or whoever sets up the virtualization stack, can decide which services the SVSM should provide to its guest operating systems and can configure the SVSM with its custom set of modules and provide only the modules that are desired in the user's environment. And this way making the SVSM highly adaptable to its users' needs. So here is a picture of how the overall user versus kernel mode architecture is envisioned. So we have the SVSM running in VMPS0, consisting of the Rust kernel, which is intended to be a rather small piece of the stack. And then we have the user-desired modules running, like the TPM, possibly live migration, and others that the user configured. So the goal is to have all of this running in a less privileged user mode and isolated from each other. Next steps, I already mentioned CPL3. TPM2 will be basically the first user, or is planned to be the first user for that. Since it probably takes a little bit more time than we anticipated to get there, there are efforts to merge a TPM 2.0 implementation at CPL0, which is something I don't endorse, but people want TPM functionality, so it might be a necessity to have that as an intermediate solution until CPL3 is ready. So this might happen. at least as an interim solution, when we have a TPM at ZPL3, it will of course be removed, and we will no longer support a ZPL0 service. We will need persistence support because there are services which need to store state. The TPM, for example, need to be able to store its state, like the EK, across reboots. The TPM can also store other secrets like disk keys and things. So there is a need to have this saved across reboots. So we need persistent support. We also want to create an ecosystem for modules where people can actually choose the modules from which they want to run in their environment, which at some point hopefully also include paravisor support modules. We want to further improve the isolation within the SVSM kernel. That is not perfect yet. So there's work to be done there. We'd like to port the SVSM or CC SVSM porter to other TEE architectures like Intel TDX. And in the future, possibly also to other hardware architectures like ARM and RISC-V once their TEE support becomes available to developers. So that was my talk about the Coconut SVSM. I hope you learned what the project is about, and I think we have quite some time for questions left, so let me know what you want to have answered.
You did a great job managing the time on that. So yeah, we will open it up to questions. I saw there was a number of questions and responses going on in the chat. So I'll invite people who had those questions to come off mute and do that. So I see Sam Ortiz's virtual hand up first.
Hey, Jörg, thanks for the presentation. Was really useful. One question, you're mentioning device simulation as part of the SVSM. Does that include Virtio backend implementation in SVSM?
So yes, we can actually emulate Virtio devices within the SVSM. Yeah, so that is possible. Whether it makes sense is also is dependent on what you want to achieve. So because it has it probably has an visible performance impact. But if your goal is to run a completely unmodified OS which does not have any confidential computing enlightenment, then this would be possible. Yes.
So I'm curious about one thing on this topic is, say you want to do a Virtio net from SVSM, and typically you're going to have to, you're going to need access to the physical device. Virtio net will basically implement the backend and eventually plug into an actual Ethernet card that is owned by the untrusted host. Is that something that you've been thinking about? Or do you have a solution for this?
So far, the solution for this is that the untrusted hypervisor actually provides an emulated device to the SVSM, and the SVSM will use that device. And the untrusted boundary is then in the SVSM, which has a smaller code base and can be easier hardened to talk to the hypervisor. And not put this on the OS. I haven't thought yet about actually assigning devices to the SVSM. But that's probably something we can think about. I haven't thought about all the implications. So, yeah.
Okay. Thank you.
Nathaniel?
Hey, I have three things. Hopefully they'll go really quickly. The first one is that there's a really interesting paper from IBM Research on a minimum hypervisor interface between guest and host, which may be interesting for your research. Particularly as you figure out how things are interfacing with hypervisors. The second question I had was, have you thought at all about provisioning of endorsement key and how that works in the SVSM TPM world? And then the third question is about the tension between composability and fragmentation of the TCB measurement as it relates to modules.
Yeah, so for the measurement question, the currently it is the case that all modules come from the RAM file system, which is part of the initial memory image. So all modules are initially measured with the hardware measurement from the platform. It's true that different configurations will create different measurements, but it's expected that the actual SVSM is built by either the cloud service provider or the builder of the virtualization stack, and then the measurements will be the same across the same basically instance types of the virtualization stack provider. Or another possibility is that virtualization stack providers basically allow bring your own firmware, which then would allow actually the end user to bring their SVSM, and then the end user would also know the expected measurement. For the TPM endorsement key provisioning, there are several ways we are thinking about. So one way is to actually generate it at the first launch of the TPM and basically validate it using the launch attestation mechanisms. Another thing is to provide an initial image for the persistent state of the SVSM once we have persistency, which then brings the question, because the persistent state needs to be encrypted and integrity protected. So we need to get a key for that persistent volume into the SVSM, which will then require some kind of key broker service and attestation service, which is available very early. So these are the things we have been thinking about, but no decision has been made yet. And about your first point, I'm not aware of that paper. It would be great if you could send me a link to it. That would be great. I would like to have a look into that. That sounds interesting.
Thank you.
Yi?
Hi. Yeah, I had a similar question about measurement. I actually raised it in the chat, and I think John answered some of it. And I think Jorg also answered a little bit of that. But I guess I just want to reinforce a little bit that my understanding is with SVSM, especially with the VTPM use case, for instance, for a kind of a general use case, I guess, we're still not looking at differentiating the measurements in the SCVSMP hardware attestation report, because that would essentially be the SCVSM image plus OVMF, for instance, and it will be the same for every platform, unless you have the kind of a bring your own firmware kind of approach that you mentioned. So as a solution to that, I wonder, I think, yeah, you mentioned that you guys are still thinking about it, but I think in general, it would be good to have some kind of predictable expected measurement, including some guess differentiation that could be reflected in hardware. I know with VTPM, we could do things in the guess and delegate the later level of the trust chain to the software in the guess. But having a differentiated measurement which is predictable and can be calculated before deployment would be very helpful, for sure.
Right, I agree with that. So for that, we are actually looking into integrating a file format called IGVM, which is basically a file format defined by Microsoft, describing the initial state of a confidential virtual machine. And any provider of a virtualization stack can then share that description file with its customers. And the customer can use that file and the configuration of the VM to calculate the expected launch measurement. And in an ideal, or in a bring your own firmware case, it would even be possible that users or customers can bring their own IGVM file, which would also be a possible variant of knowing the expected launch measurement. Yeah. So for IGVM, we actually want to make that the default launch method for the SVSM. And the IGVM file would contain the SVSM and the firmware. So
Is the
or VMIF.
Is that IGVM specification open today, or is
it is? It is open. Yeah, you can Google for IGVM in Microsoft, and I think you will find it on GitHub. There are 2 repositories.
Okay. Thank you.
Ophir?
You're talking about the case of bring your own firmware, but that requires, if we're talking about any cloud service provider, that requires that those CSPs would add support for SVSM usage. Are you aware of any cloud that has any work in that direction?
I can't comment on that.
Wise answer.
Yeah, that's better than no. Yeah.
It's very intentionally not better than no, except that no, we all get it right.
All right, Drasko?
Yeah, so this is very similar to what I wanted to ask, because you know, I recently ranted on our Slack, you know, that it's practically impossible to, with CSPs, in my opinion, you know, based on the experiments that we saw, to really have a secure VM in a sense that I understand what is the Linux that or whatever deployed in that VM. Then the answer, you know, it looked like the only possible answer would be a virtual TPM. And then we started, you know, digging deeper into the state of the virtualization of TPM in secure virtual machines. And there are 2 projects that are somehow, you know, kind of competing, or not competing, but doing the same thing. And one of them is Coconut, but the other one comes directly from AMD, and exactly dealing also with the SVSMs. So I have 2 questions. So first one would be, you know, just for the understanding of differentiation of those 2 projects that seem to implement the same thing, and if we, you know, are admitting Coconut SVSM into the consortium, then how do we look at this AMD implementation that comes directly from the manufacturer? And then the second question is, what is the opinion, you know, on these existing TPMs, knowing the state in which SVSMs are today, that there is no implementation of VTPM? What is, you know, the security of those underquote, you know, the secure TPMs that are being advertised from some CSPs, or what is any other way in which we can verify, you know, the existing PCB or let's say Linux kernel running in SVM? Those are my 2 questions.
Can I make an initial comment, which is that if there are 2 competing projects, that's fine. If they both want to become CCC projects, that's probably also fine. We try not to play favorites, although it's interesting, obviously, to hear questions like, you know, does AMD have a reference project version, which is something we heard about ARM in the last version. So I just wanted to say that quickly. Dan, you might want to add to that. Sorry if I've misrepresented or.
No, that's fine. Drasko, I was managing chat and some other things. Did you get an answer for your question then?
That's one question.
So the AMD project you're probably referring to is the Linux SVSM, right? So that was a project initiated by AMD, which was also working towards an SVSM, but with somewhat different design goals. So from what I remember, the Linux SVSM from AMD did not pursue the module model for running several modules at CPL3. Sometime after Coconut became public, AMD also somewhat shifted gears and is now contributing to Coconut. So as far as I know, they are not pursuing the Linux SVSM development anymore. So, so that's for that. I'm not sure.
Then.
Say again.
Those two may have already then collapsed together then. So.
Yeah, right.
Yeah.
So, and I'm not sure if I got your TPM question correctly. Were you asking about the security of existing CTPM implementations, or what was the question?
Yes, because if you scan, the offering from the confidential cloud providers, you will see that, there is a VTPM mentioned over there. But from my, research is that I saw only kind of hint of implementation or the beginning of implementation in both Coconut SVSM or AMD's Linux SVSM, and never saw, a complete implementation anywhere. So I'm asking you to estimate, the security, or how is it possible, that there are those already done.
So there was a PR for the Linux SVSM implementing a TPM based on the Microsoft reference implementation in C. We now have the same PR open in draft state for Coconut SVSM, basically implementing a CPL0 TPM, which we might need to have as an intermediate solution because people want an SVSM with TPM and don't want to wait for our user mode work to be finished. So I can't comment on the security of the C implementations, but I know that Rust implementations are in the works. So there are several. I know of at least 2 projects working on a Rust-based TPM implementation. So.
Okay, great. So in the interest of time, I will take the privilege of the last question, which might be the least interesting. But of the services that you suggested, there is the TPM that we've talked about at length here, migration, and then there was variables. And I wasn't quite sure what variables referred to.
That's basically support for storing UEFI variables in the SVSM. To actually isolate it from the OS, which is needed for secure boot on SCV SNP, I guess, because you don't have system management mode in a confidential VM, so secure boot is somewhat problematic. But with an SVSM, we can actually gain the same security by using VMPLs and an SVSM. So, and by storing actual UEFI variables within the SVSM, isolated from the OS.
Okay, thank you. Thanks for all the presentation and questions and answers. So we can continue the conversation as usual over the mail list. We also have Slack. I don't know if Jörg is on the CCC Slack. So probably the mail list would be best. Is that right? Jörg, would be your preference for follow-up questions before the next session?
Yeah, you can contact me via the CCC Slack. I'm there.
Okay.
My email address was on the first slide. You can also drop me an email. Let me write it to the chat again. So you can drop me an email at this email address and also ask follow-up questions. So that are the preferred ways of contacting me.
Okay, great.
So Dan, can I ask a quick question, sort of like process-wise, since it's been a while since I sort of seen a project into CCC, what's the current sort of overarching process you're going to run here?
So what we've been doing is we'll have a session like we just did that introduces the project and gets through the bulk of the technical questions about the project. And then like we just did for ILET before this, there will be a second session where we go through the project submission materials. They get more into things like the licensing questions and maybe a formal list of dependencies and so forth.
Oh, yeah.
And then seeing how we are with things, then we will potentially move to a vote after that.
Thank you.
Mm-hmm. We have the next topic on the agenda is maybe of related interest for people. I get that up. So when we were talking about what sorts of things we would like the consortium to focus on, particularly as we were dressing up ideas for our 2024 planning, the recognition that we all have a number of dependencies on the kernel and the alacrity with which we can get those patches, those features integrated into the Linux kernel is an obstacle. And one of the issues, if I just go right to and that maybe one thing that we could do as a consortium is to work together to do that in a more efficient way. So a couple weeks ago, I put up this pull request that you can get to on the TAC repository, and there's some good feedback on that issue itself, and then it's also posted on the COCO sublist of LKML. There was some additional feedback on that mail list, and then at the Linux Plumbers Conference, I got some verbal feedback as well. I have not made any changes to the original post based on that verbal feedback yet, but I intend to do that. Given the limited time today, all I wanted to do was introduce it and get maybe a little bit of discussion going. And then we can have maybe a more complete discussion if it's warranted at a subsequent meeting. The motivating case that we used for the first draft of this is the quote or the attestation API, if you like, that we had at least two different paths that were going down, vendor-specific ioctls, and then kernel maintainers decided, well, if we're going to have any of these different hardware architectures, it really would be much easier to maintain, much better for the community if there was a single way to do that. And so they eventually arrived at a config-fs approach, and we discussed that very briefly in our last meeting when that particular interface came up. But the notion here is if there are other features that we're all going to be working on that are rather similar across architectures, maybe there's some way that we can air some of those ideas before going to LKML and before starting patchwork that might be better considered with all of that context in mind across the vendors. The sort of secondary thing would be just having a sort of informal setting where kernel maintainers, people who are working on features, can discuss things that might not yet appear on LKML or may have already appeared, and get to a faster resolution than trying to go through the mail list. And then the second half of this is really about whenever we create a SIG, we want to have some sort of structure around it so we know what we're doing when issues arise. And at the same time, we want to avoid unnecessary rulemaking. And so that's really the gist of this, is that we don't want to make a bunch of unnecessary rules here. There shouldn't really be votes coming out of this SIG. The only thing that we foresaw that the SIG itself would vote on would be if we needed to go make a recommendation to another organization like IETF or TCG. But generally, what we're just looking at doing is exchange of information in the SIG, more so than making explicit decisions. And then the final thing here is just how we get underway, and tossed out the idea of meeting every other week and trying to make use of existing discussion channels where they already exist so we don't disrupt where there's already some efficient collaboration happening. Any questions on that?
So I have a comment, which is that this is the sort of area where Linux projects such as the CCC can add huge amounts of values to their member companies and to the community as a whole. Because having these sorts of conversations, if for instance, Intel and AMD sort of just got together and did this stuff, it looks very dodgy and it looks kind of antitrust and all those sorts of things. But we can do this under the auspices of the CCC and Intel and ARM and AMD and NVIDIA and Huawei and anyone else who creates chips. can get involved, and anyone else who's interested, like the kernel maintainers, and do so in a way which allows collaboration, which, because it is minuted and because it's upfront, doesn't is much less likely to run afoul of antitrust and anti-competition laws. So this is exactly the sort of thing that that the CCC should be encouraging from my point of view. So I'm very, very much in favor.
Thanks, Mike. Right, so I guess I'd ask if this looks like something that you want to see move forward. Feel free to give that feedback directly on the pull request, or I think that the community that we really want to make sure that we have engaged here is the Linux kernel maintainers. So I know we've got folks here that that participate in that community, and this is really about bringing these two communities together: our CCC community and Linux kernel maintainers. So where we don't already have overlap, we want to bring more of those conversations together. So you could also maybe more directly influence that thinking by responding to the thread on LKML in the COCO sublist. And I've got that linked, I think, in the meeting agenda notice, so you can get to it there, or I can dump that into chat later as we go in the agenda today. Right. If there's no other questions on that, we will move into our 2023 objectives. I'll try to get that screen up here. I saw Ben had pinged people directly in the document, and I don't know if you noticed if we got any responses on that while I get the document up, Ben. We still have Ben?
Ben had to drop for another meeting.
That's right. Yes, his regular conflict second half of this one. Okay, so I will answer for Ben then as we go through this. So if you're relatively new here, one of the things that we've tried to do to make sure that we are having an impactful presence as a group here is that we set some goals for ourselves at the beginning of the year. So the goals that we set in 2023 are what we have in this document. We've got a separate one that we started for 2024. And we've structured these for those who are familiar with OKRs as in that format, but if you're not, it's simply that we want to have an objective that we are trying to serve, and then we break that objective into some measurable KPIs or key results. And so for each one of these, I think 5 areas that we have spec'd out, we've got a TAC owner that's been responsible for driving some of the work for that. And Ben has gone through and tagged each of us for our areas. And the goal is that probably by the end of the next meeting, which will be, I think, our last meeting of the year, we want to make sure that we've recognized everything that we've completed here. So I'll just sort of sample a few areas to give a feel for what this looks like. One of the main points of having a consortium like this is that we are actually developing software, open source software that advances confidential computing. The project portfolio that we started with at the beginning of the year was much the same as it had as we had first initiated the CCC. So we've made an effort to get out and recruit new projects, and we saw, of course, good evidence of that in today's meeting, going through 2 of those. We've had other projects added over the course of the year, and so we want to recognize the accomplishments that we have had there. We have also gone into, we've tried to make sure that we are reflecting confidential computing as a useful security technology in other organizations, so that the overall adoption, our ability to accelerate the adoption, it's something that we're doing directly in that context. So a few things that we've done in that realm have been responding to the recent IETF statement about the risks of attestation. So we got that in a very timely way. The US government had an RFI about open source security. So as an open source organization working on security technologies, we had a lot to say about that. So our response to the federal government went up, I think in October. And we have a few of these other things. The governance, risk, and compliance SIG is where we want to do most of that work. That SIG meets on Wednesdays in the morning US time, I think. And we're looking at a variety of organizations to interface with there. One of them is the Cloud Security Alliance. So I think I see Mark Novak on. So Mark leads that SIG, and I don't know if you've got any updates that you want to give verbally here, Mark.
Well, so for 23, we are established a joint working group with CSA. We're working on helping CSA decide on the next version of CCM. So what we've discovered late in the year is that CSA is publishing a extensive, like 300+ page document on like CCM implementation. So CCM, for those of you who don't know, is the cloud control matrix. So there's going to be a 300+ page implementation guidelines document. The CCM spreadsheet itself contains a fraction of that, like a small fraction of that. So what we have done is we have gone line by line through CCM before, looking for where confidential computing can lead to better controls, and specifically adding data and use protection in some cases. It could be a small tweak to implementation guidelines. In some cases, you need entirely new control specifications because there is not exact mirror. So once the extended document is published, we're going to carry all our suggestions into that document and run it through the working group with CSA to recommend what changes might be made for CCM V next. Currently it's V4, so maybe 4.1 or whatever. So the expectation has to be set that this is a lengthy process. So hopefully there will be something published in 25, but we'll be working on it throughout 24. So separately, we are identifying potential collaborators for controls work in the rest of the industry. And again, I had to miss our sync up yesterday because of work conflict. So I have to check. Others from the team, from the JRC SIG are online, so please feel free to speak up right now. But for 24, we will identify and engage additional partners to work with in addition to the CCM work. And I've also placed some asks on the attestation SIG, where it comes to some of the things that we believe need to be done, specifically in the attestation realm, to help ease confidential computing deployments, and that's sort of a separate conversation. So again, if you're in the JRC SIG and you have updates from yesterday, and again, I'm now 2 weeks behind, please speak up now.
Okay, great. Thanks for that update. And others on the JRC SIG, feel free to chime in if you would like. Otherwise, I see in chat here a good recommendation from Chris. Lily shared some information about the work that she's been doing to facilitate cross-project discussions, and there's probably some artifacts of that we could make use of on the website. And that might get into 2024 planning. So I think maybe we'll kind of hit this last item here on 2023 as a segue.
May I just make a note with that piece of work that Lily's done is one of the first things I hope that Sal will look at when they start their work and think about how we can do stuff. So Sal is already aware of that. I think we need to because that's a large part of what the TCA can do is help with those links. Sorry.
Sure. Okay. So the fifth area here is about making sure that we develop a healthy community. And one of the main things that we have there are internships, which are not necessarily things that we have been able to staff well. So we have some outcomes that we want to make sure that we log for 2023. I think, let's say NARCS had supported a couple people. NARCS was usually quite good about that. But besides documenting the successes that we've had, Yash volunteered last session to lead this topic headed into 2024. And I think he's got some questions about what we've done historically and what we want to do in 2024. So maybe we can spend some time talking about that right now.
Right, yes. Thank you, Dan. So Kian from Linux Foundation, he actually messaged me on the chat at the last TAC call, and he brought up that Nate Waddington from the CNCF runs their mentorship program. I'll just put his bio in the chat. So I did check out the CNCF mentoring initiative. It is pretty extensive. They have over 100 mentors this year. You can I also put a link to their GitHub page in the chat. Again, the CNCF is a much bigger landscape. They have many more projects, so they can have 100+ internships. For the CCC, what I would like to know from the TAC is, before I reach out to Nate to try to understand how we should approach this, what is the CCC's goal? Are we trying to get more interns so they have more hands-on experience, to get them to work on multiple projects so we can connect, two projects that are CCC member, like CCC sandbox projects? What is our goal, and what would be the scope of the mentorship? To add APIs, to just learn, to get more people involved? What are your thoughts? And then I can build on that when I speak with Nate. Yes, Mike.
Yeah, maybe if I talk just briefly about what we've done previously, because I think it shouldn't be the only thing we do, but I think it might be helpful. So previously, this was run by, or certainly pushed a lot by Nick Vidal, and you should get in touch with him. We can provide information about that. And it was really kind of twofold. One is to get some starting developers involved, particularly from diverse communities. We used Outreachy, for instance, to help us with that. Just get some people involved with CCC so it's more visible in the industry. We didn't so much look at how we could do cross-project work, and I think that would be a really interesting thing to look at this time round. What we're going to need to do is make sure that people who are on this call who can help with those mentorships and or parts of the projects, because that is an area where the CCC has not always done so well, as we've seen with the mentoring for the projects. So I'm really in favor of this, but we need people to step up and say, probably right now, that they would be interested, or they can identify people within their organizations or their projects who can commit to helping with this. But I think doing some cross-project work and sort of building up and taking things further towards commercializability would be useful things. That's just my view, however.
Yeah, so yes, I agree. So I think there are two issues here, right? So I am mentoring so I am mentoring right now, and the person that I'm mentoring is interested in the Oculum and Veracruz projects. They want more hands-on experience. So what I'm trying to do is get in touch with the maintainers to see if there is, if there are any overlaps in those two projects where I can point her and say, hey, this project needs work where it works with Oculum in a certain way, and maybe you can help contribute something in that space. But we don't have any such list of requirements right now. Now, the projects that we've added recently, right? Certified Framework, ILET, and Coconut SVSM eventually, I see a lot of possibility where we can have interns who can assist those projects, really speak with each other. They can be the focal point. It would be a good exposure for them, and also kind of force the projects to speak with each other as they mentor this person. I think that's a great opportunity. So that's the first problem. The second problem is we can't ask people to step up till we identify which projects need help. So once we have the list of projects, and then I can set up calls with each maintainer to really understand what their needs are, what their roadmap is for the next 12 to 18 months. I can kind of piece together where certain projects overlap and can maybe work together. I can bring that to the TAC again, and then we can say, okay, who wants to volunteer in this space? So, am I breaking up?
No, you're good. At least you're good on my end. I see Drasko's got a question or comment.
Yes, sorry. Just a question about the sponsorship of those internships. So I would like to understand, is this something that is covered by CCC, by LF, or by each individual company? How does it work? Because we have, volunteer. Also, does it apply only to the accepted projects, to the incubating projects of CCC and so on? So that's what I would like to understand.
Do you want me to talk about that? Sorry, after you.
So we've funded that historically through the Outreachy program. So the consortium puts up a certain amount of money that pays for an internship. And what we'd asked was that for admitted projects that they put up mentor volunteers that facilitate those internships. What we're looking at now is, instead of or in addition to Outreachy, looking at the LFX program. But I think it would still be under the umbrella of existing projects. So projects at any level, and we really only have 2 levels now, incubation and graduated. Does that answer your question?
May I also suggest that, it's entirely appropriate and encouraged for companies who are major sponsors of particular projects to put up extra money for extra interns if they think that would be helpful. Certainly, we did that at Profion for the NARTS project. The more the merrier, really. It's a great way of getting people into your company, not to mention your project, by having interns and mentorships.
Yeah. Also, one question: what's the timeline? What is the deadline for this?
So LFX and Outreachy have different timelines. And Yash, I don't know if you look like you were about to jump in there.
I actually don't know, because I just got started this.
Yeah. So when we've looked at the past, usually we end up looking a little bit late, and we'll miss a certain milestone, but they're on a rolling basis through the year. One thing I want to put into people's heads is let's think about, particularly for voting members of the TAC, so premier members, if one of the responsibilities that we want to assign ourselves heading into 2024 is that each of us will take on a mentoring role for a certain amount of time. So we might formally suggest that in the coming meeting. So if you have some immediate reactions to that, I would love to hear it. But Sal has also been waiting patiently to get in here. So go ahead, Sal.
Yeah, but there was a very cute dog in the meantime. I think I really like sort of the alpha omega approach of getting a cohort of mentees together, making sure that each of them has an individual project or several projects where they're doing like 50-50 time. That works really well to get their skill sets up, to make sure that you get really interesting thinking because they're all communicating together, right? I think that was mentioned. One thought though, for especially for these premier members, for these oh God, sorry, I didn't know my camera was off. For these mentorships, you should really think about it as a like soft job description for your ideal maintainer, writing out not just what you want, but how you would be training them, because it's really hard for you to hire that ideal maintainer, right? This is your chance to get 3 months to train them and then hire them, right? So if you think about it that way, this is a great opportunity at low cost to build that.
Yeah, I think that's a great way to think about it.
Yeah, and we're always looking for new maintainers, right? One of the patterns we're seeing in new projects that are being added to the CCC is that they're largely being driven by one company. I don't want to generalize, but that's the pattern of the projects that have been added recently. And having an mentee or an intern work with 2 projects would be a great opportunity to add a mentor or add a maintainer who's not part of that organization, and also kind of force people from other organizations to get involved.
Yeah, I think getting maintainer diversity is one of the most common challenges for projects, and it's a great point that this is a good way to establish that.
Right, so I'll speak with Nate in the coming weeks, and I'll try to learn how the CNCF does it, and then I can share my learnings on one of the first TAC calls in Jan or Feb. Jan, actually. Yeah.
Sounds good. Okay, so in the last couple minutes that we have here, I just want to give a heads up that for the next meeting, ahead of the next meeting, we're going to ask that each TAC voting member make sure that they are self-assigned to one of these areas, and begin the work of trying to get more specific about the objective that we're going to complete. So there's sort of a template down here in the doc for you to use, but I'm going to ask that everybody fulfill their role here, who is a TAC voting member. And if you're not a voting member, but you're still volunteering, that is fantastic, and appreciate that as well. So if your name is on one of these preliminary objectives, please take the time to write up, exactly what is the objective that you're trying to fulfill, and then what are a few measurable things that we can do over the course of the year by all working together here. And with that, I think I will draw us to a close. So any last questions, concerns, comments before we wrap for today? No? All right. Well, thanks to everybody again around the globe. Great to have such a wide variety. Oh, go ahead, Drasko.
Yeah, one quick last question. Maybe it's too early, but for 2024, are there any planned face-to-face meetings of the consortium? Do we want to start that practice as well?
So we should certainly look at something over the Confidential Computing Goods Summit, which is the end of May, early June, I think. We should think about other places that lots of us would like to be. Maybe RSA is another one to think about. But yeah, great question. Yeah,
so last week, Kate George from Outreach was on and talked about the conference schedule that Outreach has prioritized. So there's a wide list of conferences, and the Outreach Committee has prioritized a subset of those that they think are most relevant. And so those are all good opportunities for meetups. But I'm not aware of anything that's specifically, hey, we as CCC are just going to meet. What a great idea.
Yeah, so just from my previous experience as I was on a technical steering committee from LF Edge, so Linux Foundation Edge, and especially Edgex Foundry project. we had a meeting regularly every 3 to 4 months, even, or at least twice a year, dedicated face-to-face meeting of the whole community of the consortium, and I think it's very important and very nice experience, actually.
Yeah, it sounds great. All right, thanks everybody, and look forward to seeing everybody again pseudo face-to-face in 2 weeks.
Thank you.
Thanks, bye.
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 Thanks, Sam. Thanks, everybody. Bye-bye.
Thank you. Bye.